If I turn it into a fraction, equal a fraction, I can just solve it by cross multiplying. Okay, so what I'm going to do is say, all right, what's the common denominator going to be? Over here we got an x plus 3, and then we got a 3. The common denominator here, trying to write, would be to take and multiply each denominator by the other denominator. But when I do that, again, I want to say this: if I multiply the bottom by 3, I got to multiply the top by 3 to keep it all equal fraction. And then over here, this guy is going to need to get multiplied by x plus 3 over x plus 3. Now they'll have a common denominator. Let me put this one in parentheses, because if I don't, I'm liable to think that I've got x plus 9 there if I don't put that in parentheses, aren't I? Just because the way it just looks on the paper at that point, especially if you get interrupted and you look back down. Okay. Now, on this first fraction, 5 times 3 is 15. And then I'm just going to leave this one this time. I can write this as 3 times x plus 3. And I don't know whether I want to leave it or not. I may end up multiplying it out. A lot of times what I'm looking for is sometimes when I get down, before I even start cross multiplying, there's sometimes things will cancel out and I can reduce a fraction. And you just never know if that's going to happen or not. Over here I've got 2 times x plus 3 over x plus 3. 3 times x plus 3. And I forgot to put my 1 down, didn't I? Now over here, when I go to simplify this, they've got the same denominator. I think, you know what, let's just go ahead and multiply that 3 times x plus 3 out right now. What is 3 times x plus 3? Right here. And that'd be 3x plus 9, right? So my denominator is going to be 3x plus 9. If I come over here and put these together, took these two fractions into one, I'm subtracting fractions here. This minus 2 needs to get distributed to both terms. So it's minus 2 times x. That's going to be a minus 2x. And it's a minus 2 times a 3. That's going to give me a minus 6, right? I have to write this down because I have to go to a new slide. Okay. I could turn the other side into a fraction, couldn't I, by just putting 1 over 1? Is there anything I could clear up on the left-hand side before I start cross-multiplying? Yeah, this part right here. 15 minus 6 is 9, right? So it would be negative 2x plus 9 over 3x plus 9 equal 1 over 1. Oh, this cross-multiplying is going to be real difficult, isn't it? Not. When you cross-multiply, you get 1 times 3x plus 9 is 3x plus 9. Put your equal sign down, and when you go do the other diagonal, it's just 1 times negative 2x plus 9, which is just negative 2x plus 9, right? So that cross-multiplying was really easy to do. What should I do now? Got x's on both sides. I'm going to move them to one side, right? So wouldn't it be easy to move those minus 2x's over by just adding them to both sides, and that would make all my x's positive. So 3x plus 2x is 5x, right? And I got a plus 9, and on the other side I got a 9. How am I going to solve for x?
First, you want to subtract 9.
Subtract 9 from each side, thank you. So subtract 9. And I get 5x is equal to nothing?
Yes, equals 0.
0. I got, yeah, 0 is a number. Let me bring that up here. 5x equals 0. And if I divide both sides by 5 to get the x by itself, what's my answer going to be? Just 0. And 0 divided by 5, 0. Now, there's two ways to do this, but this one is kind of like number 2. I could get a common denominator, but I want to kind of just show you that sometimes there's something else I could do too. Isn't there an x on the left-hand side in the denominator and an x on the right-hand side in the denominator? I could get a common denominator of 3x on the left-hand side, but look what would happen. I just want to show you something, just so that you're kind of learning that sometimes thinking outside the box is a good thing. What if I did this? I could get a common denominator, but what if I moved the 4 over x to the other side? What would happen? That would cancel out, and what would I have left?
A third equals 5 over x.
Yeah, 1 over x plus 4 over x is 5 over x. Isn't that a lot easier to do than getting a common denominator? Sometimes you get problems like this. And number 2, that's why I really struggled whether to work it that way or not. No, not number 2. It was number, I don't remember. There was one earlier we could have worked it this way, and I chose not to. Number 5. This is a lot like number 5. I could have gotten a common denominator, but if you look, wouldn't it be just as easy to move, since there is an x on one side and an x in the denominator on the other side, if I move it over, all of a sudden I got a fraction equal a fraction. This will clear up really quickly, won't it? Because can't I just cross multiply now? What is 1 times x? X. And what is 3 times 5? 15. That was a lot faster than getting a common denominator. So, a lot of times if I see things like that, I want to do it. I don't have to do it that way. I'll do it the other way just to show you that because sometimes is that going to occur to everybody? Maybe not. Yeah, I know it because I'm looking at it and I've done enough math over and over and over every day all day that I see stuff like that. But maybe that's not what you would have done. So let's look at it a different way. 1 over 3 minus 4 over x equal 1 over x. If you didn't see that you could do that, this is what you would have done. You would have said, okay, what would a common denominator be on the left-hand side? You got a 3 and you got an x, right? I'm just looking at the left-hand side, not even worrying about the right-hand side, because I'm trying to get the left-hand side to be one fraction. Wouldn't I need to multiply this guy by x over x and this guy by 3 over 3? Right? That would be something I could have done. And then I would have had x over 3x minus 12 over 3x equal 1 over x. This is how I worked problem number 5 when I did it, just because I kind of wanted to start off showing you the same technique all the time. And it's still going to work. I have a feeling we may have something happen here that's going to create a problem. I want you to kind of notice that I got one answer the first time. Let's see what happens the second time. I would have x minus 12 over 3x equal 1 over x. Wouldn't that simplify to that so far? Now, what if I cross multiply? What's going to happen? This is interesting because this is something really good to note. To compare the two solutions, different ways of doing this, and compare the solutions and see which one gave us more problems. 1 times 3x is 3x. Ooh, x times x minus 12 is x squared minus 12x, isn't it? Okay. That's a little, now I'm already kind of seeing that doing this is kind of creating a harder problem. It doesn't mean we can't solve it. Let me get that x in here. All right, so if you remember, when I got a square, don't I have to move everything to one side of the equation, right? So let me move that 3x over. I will subtract it from both sides. And the reason I'm doing that is when I have a square, in order to solve it, I got to get 0 on one side. So I'll just move all the terms to one side. Here's what I have now. X squared minus 12x minus 3x. Isn't that going to be minus 15x? Right? Okay, so now I have a square I'm trying to solve, whereas that other situation cleared it up really quickly, didn't it? How would I solve this if I hadn't thought to move that to the other side, and this is the technique I chose? I know I have to factor something. What do I always start with when I factor? Checking for a GCF, right? Greatest common factor. Want an x, divide out of both of those. So I'll take an x out of both of those, and I get x times x minus 15 equals 0. X squared, take out of an x would leave me an x. Copy down my subtraction sign. 15x, take out the x would be a 15. How many answers am I going to get here? 2. I'll say, okay, either x is equal to 0, because when you multiply two things and they give you 0, either this factor is going to be 0 or the other factor is going to be 0. So one of my answers would be x equals 0, and the other one would be add the 15 to both sides, x equals 15. So you might think you have two answers. We only got 15. Why did we not get a 0 the other way? By the way, will 0 even work? what's going to happen when I plug 0 in right here, even, and also over here? When I get a 0 in the denominator, is that good? No, the earth opens up and swallows us because we divided by 0. We can't put 0 in there, can we? So by using the technique that we use here, we introduced a solution that won't work, and we got to throw it out. Oh, that one won't work, so I can't count it because if I plug it in, it's going to make my denominator 0 over there, so I can't use it. So that's kind of an interesting thing to know. When I did it one way, I only got the one true answer, right? But when I got a common denominator, because I multiplied through, most of the time this happens when we multiply through by this variable here. See how over here I had to give this guy an x because he didn't have one? A lot of times when I multiply through and get a common denominator and there's a variable involved, it introduces solutions that won't work when you get through and you go check it to see, can I plug it in and actually get it to work? So the other way was actually kind of better because I didn't have to worry about it, but I might not have thought to do it the other way. So I can still do it this way, but when I do it, I better be careful about looking at all my answers and seeing when I plug each one of those in, is there a place where I'm going to get a 0 in the denominator? Hey, yeah, these two that I circled in green, they won't work, will they? So my only answer is still 15 there.